Chapter 6 Review Podcast. This session covers vectors. Okay, so we're finding the component form and magnitude of a given vector W that has initial point -8, -12, and terminal point 4, 1. So there are a couple ways to do this. I generally like to sketch it out, and it makes a lot of sense. So if we had the coordinate plane and we went -8 and down 12, we would arrive at this point right here. That's our initial point. That's our initial point. We'll call that point P, even though it's not labeled here. We'll call it point P. And then we've got point Q, which is at 4, 1. So 4, 1. So 4, 1. So that right there is our vector. And notice how to find component form, all we're doing is we are writing it in the form you want kind of your x component. What is it doing in the x direction? And then you want the y component. That's what component form is. So what we're looking at is we're trying to figure out, okay, based on this vector we've drawn here, what's it doing in the x direction? And what is it doing in the y direction? Notice how we're going right and then up. So those are the x and y components. So how far did it go in the x direction? Well, we've gone -8 plus another 4, so that's 12 units to the right. So we know the x component is going to be 12. And the y component, we go from -12 to +1, so that is 13 up. So that is our component form. That's using graphical analysis. Now, there is a formula for this too, where we just take the terminal point and we subtract the initial point. So notice how we go for the first one. The x's, we do 4 minus -8. That's 4 plus 8, which is 12. And the y component, 1 minus -12, which is 13. So that's how we arrive either way at a component form of 12, 13. All right, number 8 and 9. So we are doing some vector operations. So we have, for part A, we're doing 2v plus u. So we do 2v plus u. So for part A, we have 2 times this one. So that would be -2, 10, -2, -20 actually, plus u, which is -5, 2. Remember, we just combine like terms for this. So -2 plus 5 is -7. -20 plus 2 is -18. So that is the first answer. All right, for part B, we're doing u minus 3v. So we're taking vector u, which is -5, 2 in component form, and we are subtracting 3 times vector v, which is -1, -10. So we've got -5, 2, minus, we just distribute, -3, -30. And now we can actually perform this. -5 minus -3 is -5 plus 3, that's -2. And then 2 minus -30, it's 2 plus 30, which is 32. Okay, now for part C. Change colors here. So for part C, we got 5u minus v. So 5u minus v, we've got 5 times -5, 2, minus v, which is -1, -10. So we've got -25, 10, minus -1, -10. So -25 plus 1 is -24. 10 minus -10, that's 10 plus 10, which is 20. So those are our 3 solutions for A, B, and C. There we go. All right, same thing goes for these. It's just these vectors start out in terms of I and j rather than in component form, although it still communicates the same idea. So remember, the vector 2i plus 3j is the same thing as the vector in component form, that's 2, 3. So again, same thing. All right, so again, for part A, I've got 2v plus u. So we've got 2 times the vector v, which is negative I. Actually, I can rewrite it like this. We got negative I minus 2j, and then plus u. So we got plus vector u, which is 2i plus 3j. And we can distribute and combine like terms. So we got negative 2i minus 4j plus 2i plus 3j. Now we combine our i's, combine our j's. That's 0i, so I don't have to write that at all, minus j. So it's just negative j. I'll write that a little smaller, negative j. So that is part A. All right, changing colors for part B. Go orange. All right, so we've got part B, which is u minus 3v. So we've got vector u, 2i plus 3j, minus 3 times vector v, which is negative I minus 2j. All right, so distributing. So negative 3 times negative I is plus 3i, and negative 3 times negative 2j is plus 6j. And I've still got my 2i plus 3j, so now I can combine like terms. i's turn into 5i, 3j and 6j make 9j. So 5i plus 9j. That's our answer for part B. And finally, part C. So we have part C, 5u minus v. So 5 times vector u, which is 2i plus 3j, minus vector v, which is negative I minus 2j. So we can distribute and then combine like terms. So we've got 10i plus 15j plus I plus 2j. We combine like terms. 10i and I become 11i. 15j and 2j make 17j. So 11i plus 17j. All right. Okay, so finding a unit vector in the direction of 6i minus 4j. Now remember, a unit vector is just a vector that has a magnitude of 1 that's in the direction of this vector. Now, magnitude, remember, that's the length of the hypotenuse. And we do have a formula for a unit vector. It is right here. So that means the vector v so that's the vector. So that's vector v divided by its magnitude. So that's the magnitude of vector v. Because we're just taking the vector, dividing by its magnitude. All right, so there's vector v. So in order to be able to divide it by its magnitude, we have to know its magnitude. So remember, the magnitude of vector v just follows the Pythagorean theorem. Magnitude is simply the hypotenuse, the length of the vector. So magnitude squared equals 6 squared plus negative 4 squared. So if we square root this, we can say the magnitude of vector v equals the square root of 36 plus 16. So that'd be the square root of 52. Okay. So square root of 52, let's go ahead and reduce that. So we've got 4 times 13, so square root of 4 times the square root of 13, so that makes it 2 root 13. So that's the magnitude of vector v, 2 root 13. So now we just got to take vector v and divide it by this. So we've got vector v divided by 2 root 13 is equal to 6 over 2 root 13i minus 4 over 2 root 13j. All right, now all we got to do is simplify. So I've got 3 over root 13I minus 2 over root 13j. And if you want to rationalize, I will accept this answer right here. That's our unit vector. But if you want to rationalize, you just multiply both by root 13 over root 13, and your answer would be 3 root 13 over 13I minus 2 root 13 over 13j. And that's the rationalized version of the answer. All right, part B. Find the direction angle in degrees of the vector 6i minus 4j. Round to the nearest tenth. Okay, so we're finding direction angle now. Now remember, all direction angle is the angle from it to our direction vector, or to our vector, from the positive x-axis. So 6i minus 4j, notice how if I plotted that in component form with the initial point at 0, 0, 6 to the right and 4 down would be about right there. So that would be our vector. So therefore, our angle, our direction angle, is this angle. That's the direction angle we're looking for, the one in red. So we got to figure out what that angle is. So it's pretty logical if you know that for anything in the fourth quadrant, if we find this angle, the pink one, let's choose a different color actually. Let's choose black. So if we choose this black angle, if we find that, we know that the red angle, to find the red angle, we would just subtract this from 360, because we know the red plus the black is that. So we can find that black marked angle, that reference angle, by just knowing our sides, which we already know are 6 and negative 4. So again, I don't have to worry about them being negative because I want the reference angle, not the actual angle, as if it were we define it from the positive x-axis. So we say tan theta equals 4 over 6. Do theta equals inverse tangent 4 over 6. And we throw it in our calculator. Second tangent 4 over 6. We get 33.7 degrees. So 33.7 degrees. So that's the black angle, right? So therefore the red angle, is going to be 360 minus 33.7. So I've got 360 minus 33.7, which is 326.3 degrees. And that is the direction angle of our vector. Notice how if it were in this quadrant over here, again, no matter where our vector is, so that's our answer to this problem. But let's just talk about a couple hypotheticals. So if we had a vector, let's say it was located or directed in the second quadrant, then we'd be looking for this angle as our direction angle. So we'd find this one using trig and then set it up that way. So that's direction angle. All right, next, find the component form of vector v. Actually, I didn't quite address that enough. So if we had an angle in the third quadrant, like here, or a vector in the third quadrant, then this would be our direction angle. So again, it all depends on which quadrant you're in, but it's measured from the positive x-axis and ends at our vector. All right, component form of a vector with a magnitude of 12. It's in the same direction as u equals 3i minus 5j. Okay, so the easiest way to do this problem is first find the unit vector. Because remember, the unit vector will be in that direction and it'll have a magnitude of 1. So then all I have to do to that is then multiply it, use scalar multiplication, and multiply it by 12. And that will get us to our answer. So 2 steps: find the unit vector in the same direction as this, and then multiply it by 12. Because that will, remember, the unit vector is a magnitude of 1. And if we want to get it to 12, then we would just multiply it by 12. All right, so unit vector. Remember, unit vector, we take our vector and divide it by its magnitude. So we look at magnitude of vector u. So magnitude squared equals 3 squared plus negative 5 squared. Remember, this is always positive numbers. So I've got the magnitude of u squared equals 9 plus 25. So that's 34. And then I'm going to square root it to get the square root of 34. It's a distance, it's always positive. So that is the magnitude of u. Okay, so now we need the unit vector. So we just divide this whole thing by root 34. So we do 3i minus 5j all over root 34. We can just write them separately. So we got 3 over root 34 I minus 5 over root 34 j. All right, and now I multiply this by 12. So multiply by 12. So this whole thing times 12 now. Let's change colors to show this second step. This whole thing times 12. So I multiply the 12 in. Remember, you multiply by only the numerator because this is 12 over 1. So we've got 36 over root 34 I minus 12 times 5, that'd be 60 over root 34 j. And that is one version of the answer. I would accept that version. Now, but if we want it fully simplified and rationalized, then we would say that it is, we multiply by root 34 over root 34 to get 36 root 34 over 34 I minus 60 root 34 over 34 j. Then this simplifies a little more because 36 over 34 is 18 over 17. So it's 18 root 34 over 17i minus 30 over 17 root 34j. So that is the fully simplified and rationalized version of our answer. But again, this one is perfectly acceptable for full credit. All right, dot product, dot product. So dot product. Remember the dot product formula. Dot u dot v. If u equals u1 comma u2, whoops, u1 u2, and v is v1 comma v2, then u dot v is basically we just multiply the x's. So it'd be u1 v1 plus multiply the y's, u2 v2. All right, so find the dot product. So remember, this is our u1. Remember, this is our x. We just multiply our x's. It's just the multiplication of the x's. So u dot v equals negative 9 times 1. Remember, that's u1 v1 plus u2 4 times v2 2. So it is negative 9 plus 8, which is negative 1. So that is our dot product. All right. And finally, we got finding the angle between the vectors. And the angle between the vectors. And remember, we have a formula for this. You can use logic for this. That is a perfectly acceptable way to do it. You could plot each one, find the angle, their reference angles, and then compute the angle between them using just the idea of complementary and supplementary angles. But there's also a formula that is provided for you. So formula provided. Formula for angle between two vectors. It's cosine of that angle equals the dot product of u and v over the product of the magnitudes of u and v. So we've got cosine of this angle. I'm going to use theta instead of a. It doesn't really matter what that variable is. So this is the angle we're looking for. Cosine of that angle equals the dot product. That'd be u dot v over the magnitude of u times the magnitude of v. So that's what we need. We need three things. First, we need a dot product, u dot v. So that is the product of the x's. That'd be 7 and 0. Notice how there is no x for this one. So it's 7 times 0 plus, remember this one can be rewritten as 7 comma 2 and v as 0 comma negative 4. Remember, there is no I term, it's only a j term. So that's where we get 7 times 0 plus 2 times negative 4. So we get negative 8. So negative 8 is our dot product, so we can substitute that in. So negative 8. All right, now we need magnitude of u and magnitude of v. Well, magnitude of u follows the Pythagorean theorem here. So we'll say u squared equals 7 squared plus 2 squared. So that would be u squared equals 49 plus 4, which is 53. And take the square root. So magnitude of u equals the square root of 53. So we can replace that down there, square root of 53. And we got the magnitude of u. Just going to change colors here. Now, one thing we notice with magnitude, this has an x-coordinate of 0. So the magnitude is actually just negative 4, but I can prove it with the Pythagorean theorem as well. So magnitude of v squared equals 0 squared plus negative 4 squared. So it'd be v squared equals 16, and then the square root of that is just 4 again. All right, so this is times 4 down here. So we have cosine theta equals this. But now we're not interested in what cosine theta is, we're interested in theta. So what we have to do to finish this thing off is take the inverse cosine of each side. So that'll give us theta by itself. So inverse cosine of negative 8 over root 53 times 4. Be real careful when you put this in the calculator. Make sure you put parentheses. If you put all this all at the same time, make sure you put parentheses around around this down here. Let me show you that in the calculator. So inverse cosine, second cosine, of negative 8 over root 53 times 4. So negative 8 divided by parentheses square root of 53, 53 times 4. And there we go. And we get that the angle between these two vectors is 105.9 degrees. 105.9 degrees. And there we go. And that concludes part 2 of the chapter review.